Hi, welcome back to my channel. So thank you so much for your undying support, and this time we'll be continuing with the mathematical expression. So last time we have done discussing with the binary operations, the addition and the multiplication of mathematical expressions, or we're taking the operations of polynomials. Now this time we'll be taking steps further. We will discuss a lot of rules, shall we say, techniques in performing basic operations of mathematical expressions. But before we start, let me discuss you first the laws of exponent. I'm including this topic for the mathematical expression in the sense that I can see that the laws of exponents rule have played so much an important role in performing the basic operations. In that way, we will be able to determine if what we're doing is actually right or what we're doing is actually wrong. So here is the laws of exponent. Um, okay, provided that we have an a as an element of real number, and our mn is an integer, then number one, we have this. Okay, so this is somewhat a review on the previous video we had, that when we multiply terms in the polynomial, such terms have actually same base, so they have the same a, then we only have to add their corresponding exponents. So example, you have x squared times x cubed, so you just simply copy the x, like what we did with this rule. We simply copy the a and we add the exponent. That's it. Okay, for number two, this will actually hold, provided that your a to the m is not 0. That is. So this is just the same as a to the n raised to m. That's it. Okay, number three, provided that our a to the n is not 0, then we have three cases. Either we get m minus n, we get 1, or we get 1 to the a to the n, 1 over a to the n minus m, if m is greater than n. If we get 1 if m equals n, and we get this if n is greater than m. That's it. Okay, let's take for example x cubed over, let's say this is 4, and x squared. So this is our m, this is our n. So since the m here is greater than n, so we follow this rule. So we copy this x, and we simply get 4 minus 2 equals 2. So therefore you have x squared. That's it. Now let's take another case. X to the 3 over x to the 5. So this is our m, this is our n. In this case, n is greater, so therefore we follow this rule. X to the n minus m. So you get this. provided your x to the 5 is not 0 and your resulting x to squared is not 0. Otherwise, of course, that's not defined. That's it. Okay, so number 4 rule. We have this. So I'll just include b here. So we have this. We have, that's it. Example, x, y, x squared, y. So we have 3, so you'll have x to 3, y 3. So according to the previous rule, so we have x to the 6y cubed. That's it. Okay, so number 5 rule is we have this. We'll have a to the m over b to the m. Provided your b is not 0 and your b to the m is not 0. Otherwise, you'll get your expression and define. Okay, so now that we are done talking with the laws of exponents, so we'll be discussing a very helpful tool in order for us to discuss further, solve further about the polynomial expressions. So this is very helpful in a way that if ever two multiplicants, like we're multiplying expressions, have the same have corresponding patterns. So let's consider this one here. Let u and b be any real number, so any terms or any expression, or let's say 3x is actually a real number. So let u and b be any real number. The number 1, these will hold. Okay. Now, it would be better if you will be able to memorize formulas of special numbers. It would be better if you will be able to familiarize. But again, as what I have mentioned from my previous videos, I forgot what video was that, but I could say that I don't agree with the idea that there's actually a technique for solving math. I think it's actually following the rules. Maybe you will be able to solve it easily in the sense that you have a lot of experience solving math. So there are times that when we are going to multiply expressions, it wouldn't be, I mean, it would be hard for us to figure out what type of special products we're going to use. But if you have done a lot of exercises, a lot of experience in solving that, maybe it would be easy for you to determine what type of special products you're going to use. Now, this time, we'll have to play the basic first. Now, this is actually the special products u plus v equals u squared plus 2ub plus v squared. Now, if you will be able to remember this, and that would be fine. But in a case that you won't be able to remember that, that will still be easy. I'm sorry, this should be squared. Remember that u plus b squared, b quantity squared, is the same as that. Okay. Now, as what we've done on the last video, we can simply treat one of the expression by partitioning, so that you can partition this here. So u multiplied by u plus v multiplied by u plus v. So you simply get u squared plus uv. Okay, you distribute, and you distribute that, you get vu or uv plus v squared. So remember, this is 2uv. That's it. Okay? Now, why I'm presenting this? I'm presenting this because this is actually the proof why we get this formula. Let's take, for example, how do you multiply 4x plus 1 times 4x plus 1? So they have the same, the same expressions. So this is just 4x plus 1 squared. So using the formula, you treat this 4x as u, and you treat this 1 as v. So your u is 4x, and your v is 1. So therefore, you start with u squared, so you have 4x squared plus 2. Your u is 4x, your v is 1, and that's b squared. So therefore, you get 16x squared plus 8x plus 1. That's it. Okay, so now that we're done with this u plus b, this one, remember that there's a corresponding additive inverse for that. Remember, subtraction is an additive inverse of addition. So if I instead use minus sign here, or subtraction, instead of addition, the thing that we get is only here. So simply, if you get u plus v quantity squared, you get this. But if you take u minus v quantity squared, you get that. Okay? So example, you have 3x minus 1 squared. So we use the formula u minus v quantity squared. So that's actually 3x squared minus 2u. This is u, this is v, and this is v squared. So you'll get 9x squared minus 6x plus 1. That's it. Okay, so number 2 that we're going to discuss is this. Now, if you see patterns like these that they're actually the same expressions, like the first term is actually the same with the first term of the second expression. The second term of the first is actually the same as the second term of the second expression. The only difference is that the operation, it's addition that we use and subtraction on the second. Then this is actually the formula. This is actually the answer. Okay, now how do we believe on that? So we'll have to see the proof why we get this. So remember that u plus v, u minus v here. So again, we partition one of the expressions. So we choose this to be partitioned. So you have u times u minus v plus v times u minus v. Okay? Now multiplying this, you get u squared minus uv plus, if we multiply v times u, you get vu or uv minus v squared. So this becomes 0. So therefore, you only get u squared minus v squared. That's it. Okay, let's consider this example. 3x minus 1, 3x plus 1. So this will hold on the, this case will hold for number 2 because they have the same first term, they have the same second term. The only difference is that this is minus, this is plus. So this will still hold. So you'll get 3x squared, 3x quantity squared, because 3x is our u, minus our v, which is 1 squared. So therefore you get 9x squared minus 1. That's it. Okay, so the next special product that we're going to present is this. Which is the same as okay? Now, we'll present a proof for that. Now, remember that this u plus v, quantity 3 to the 3, is actually the same as u plus v squared, u plus v. Now, observe that this is already solved by number 1. So, this is already u squared plus 2uv plus v squared times u plus v. Okay? Now, I'm going to choose this to be partitioned. So, u times u squared plus 2uv plus v squared plus the v here times u squared plus 2uv plus v squared. So, distribute this, you'll get u cubed plus 2u squared v plus uv squared. Okay? Plus, you get this, u squared v plus 2uv squared plus v cubed. Now, this is the same as this. So, they have the same variable, u squared v. The coefficient is 2, the coefficient is 1. So, we add this one, you'll get 3. Okay? Now, they have the same variable, uv squared, and this is also uv squared. So, the coefficient here is 1, the coefficient here is 2. Add them together, you'll get 3. uv squared plus v cubed. That's it. So, this is now the proof why we get this formula. Okay? So, let's consider this example. 3 plus x cubed. So, we don't have to do this long expressions anymore. I mean, long method. Instead, we use this formula. So, we treat this as u, we treat this as v. Okay? So, our u is 3. Our v is x. So, therefore, you get u cubed, so that is 3 cubed, plus 3u squared, so that's 3 squared, and our v is x, plus 3u, so 3v squared, x squared, plus v cubed, so that's x cubed. So therefore, this is 27. This is 3 times 3 squared, so this is 9 times 3, you get 27 x, plus this is 9, so you 9x squared plus x cubed. That's it. Okay? Now, like this number 1, we determine the expressions, the equivalent expressions of these when this is minus. So, what if this is minus? So simply we have to, instead of using plus here, we use minus here, and we use minus here. Now, well, let's see the proof. So, I'll erase this first. Okay. So, this is minus. So, this is now minus. This is also minus. Now, if this is minus, according to rule number 1, this becomes minus here. So, this becomes minus here. This is minus. This is minus. Okay. We get u cubed minus 2u squared v plus uv squared. This is minus, so we get minus u squared v. This becomes plus because according to the rule that we've discussed on the last video, this becomes positive. So that's plus 2u v squared. This is minus, so you get minus v cubed. So therefore, you get u cubed. This is with this. So that's 3u squared v plus this and this. You get 3uv squared minus v cubed. That's it. Okay, example. X minus y cubed. So our u is x. Our v is y. So therefore, that's u cubed. So that's x cubed minus 3u squared, that's x squared, v, that's y, plus 3u, which is x, and our v is y, v squared minus y cubed, so v cubed. So therefore you get this. That's it. Okay, so the next special product that we're going to use is this one. This is equivalent to this is very quite short when you multiply this. Now, what are you gonna remember on that? First is the first term, you have to evaluate if that's a u and that's v. Make sure that the second expression is of the form u squared v squared on the last term, but the middle term is the product of u and v, but it's negative when it is positive here. Okay? So let's see the proof on that. U plus v, that's u squared minus uv plus v squared. So you distribute, you partition this, so that's u squared minus uv plus v squared plus v, u squared minus uv plus v squared. So that's u cubed minus u squared v plus u v squared plus u squared v minus u v squared plus v cubed. So this is already cancelled. So you're left with this. That's it. Example, 3x plus 1 times 9x squared minus 3x plus 1. So we will have to check first on the multiplicants if they're actually following the rule. So first you have to evaluate this. Because this is binomial, you have to imagine this 3x plus 1 as u plus v. Now suppose u is equal to 3x and your v equals 1. Now check on the second expression first. If it doesn't qualify, then that's not the special product that we're going to use. We'll have to use somewhere else or something else, or we can use a different method aside from special product. Now, our u is 3x, our v equals 1. So let's see if it satisfies first on these expressions, otherwise we cannot proceed with multiplication of using special products. Now, our u squared, if we get the square of u, you get 9x squared. So this is okay. Now, if we take v squared, this is 1. That's okay. Now, how about the product of these? The product is 3x. That's okay. And since this is positive, so it should be negative on the middle term. So it satisfies. So therefore, we can proceed with the multiplication using this formula only. So that's 3x cubed plus 1 cubed. So we get 27x cubed plus 1. Now, there are a lot of questions like you have to multiply expressions that looks like we're supposed to be following with the special products, but it's actually not. Example, 3x plus 1, 9x squared plus 3x plus 1. This actually satisfies the u squared. This actually satisfies the v squared. This actually satisfies the uv, but this is not. Because this is positive, it should be negative. Therefore, we cannot proceed with this formula. That's it. Now, what happened if instead of this as positive, we use this as negative? So you have to check that instead of this as negative, you have to check it's positive. And we can proceed with this formula. That's it. Okay, so now that we're done discussing with the major 4, special products. There are actually a lot of special products, but actually those are corollaries to this major 4. Now, now that we're done with this major four, so I'm gonna name this. I don't know if it's actually the same name with the authors of the book, but I call this number one as square of binomial. In the sense that this is actually binomial and we take the square. So it's square of binomial. Now, this is actually difference of two squares. Not because of this, but on the right side of the equation. Why? We take the difference of the two square terms. That's it. Now, this is actually cube of binomial. Because this is binomial and we take the cube of this binomial. And this is actually sum and difference of two cubes. Why? Because I take the sum and difference of two cubic term. That's it. Okay, so let's consider examples here on what we've discussed about special products. So number one, 7s plus 2t times 7s minus 2t. Now, this is actually following the special product. So this is actually the u and the v. The u and the v. So they have different signs. This is positive, this is negative. So you just have to follow 7s squared minus 2t squared. So you'll get 49s squared minus 4t squared. So this is following the rule u plus v times u minus v, and you get u squared minus v squared. Okay? Now for number two, for number two, so this is actually the rule for u plus v squared equals u squared plus 2uv plus v squared. So this is our entire u. So you'll get 3xy squared plus 2u 3xy. V is 2 plus v squared. So you'll get 9x squared y squared. So according to the laws of exponent, you have to distribute these individually. Okay? So 3 squared, so that's 9x squared y squared. Plus, you multiply them, you get 12xy plus 4. That's it. Now for number 3, this is for the third rule that we have. So that's this is u minus v cubed, so you'll get u cubed minus 3u squared v plus 3uv squared minus v cubed. So our u is 3x, our v is 2, so therefore u cubed, so that's 3x cubed, so that's 3x cubed minus 3. What's your u? 3x squared. Our v is 2 plus 3, our u again is 3x. Our v is 2, and that's minus 2 cubed. So therefore you have that 27x cubed. This is 9x squared times 3, 27 times 2, you get 54. Okay. X squared. And this is 3 times 3x, you get 9x times 4. So that's 9x, that's 36x plus this is 8. That's it. Now, how about for number 4? So number 4 looks like a special product we've discussed earlier. The rule special product number 4. Let's check if it satisfies first, because remember this is u plus v, that's u squared minus uv plus v squared. Now let's check. This is our u, so u here is 4, and our v is y. Okay. Now we take the square of u, you get you'll get 16. So that's correct. You take this v squared, you get y squared. So that's correct. You take u times v, so that's 4 times y, you get 4y. Now this is plus, so you have to check if this is minus, this is plus. So this is not the special product that we're going to use. Therefore, the only way we can do that is just the usual, or like the classical one. So we partition these into 2, so you have 4 times this. So 16 plus 4y plus y squared plus y times 16 plus 4y plus y squared. So you get 64 plus 16y plus 4y squared plus 16y plus 4y squared plus y cubed. Therefore, you'll get 64 plus, this is 32, plus 8y squared plus y cubed. So for the, some books would actually recommend that for the purpose of the elegance of the equation or the expressions, you write this first because it has the highest degree compared to the rest. Okay? And that's, so I'm actually recommending it to you. I'm not gonna write it now. You just have to continue it in your own. If you have a question, you can comment down there or you can message me if you know me. Okay? That's all. Okay, so let's consider another example here. How about this expression? 3x plus y plus 1 quantity squared. Can we be able to apply the special products? So far, what we have remembered is that the first is u and v only. The second is about u and v. The third is about u and v, and the fourth is about u and v. So there's no w there. But if you can see, this is trinomial. This is not binomial. Can we be able to apply a special product on that? The answer is yes. Okay, how? You can group them, actually, like you can group this or you can group that. So let's say I can group these, instead of writing 3x plus y plus 1, I'll write this 3x plus y plus 1. So I'll treat u equals 3x and I'll treat v equals y plus 1. So therefore, following the special product as u plus v squared equals u squared plus 2uv plus v squared. So I'll have u squared, so that's 3x squared plus 2u, 3x. V is y plus 1 plus v squared. So v is y plus 1. Okay? Now this is already 9x squared. How about this? This is 6x, but you can distribute this because this is actually binomial. So 6x times y, you get 6xy. 6x times 1, you get 6x. Plus that. So it looks to me that we need to use this again. So this time, I'll use this as u and I'll use this as v. Okay? So times u squared, so that's y squared, plus 2uv, uv, plus v squared. So therefore, I'll have 9x squared plus 6xy plus 6x plus y squared plus 2y plus 1. That's it. Okay? If you have a question, you can comment down there. Okay? So, what about if I'll have... Okay, that's simple. You can treat this as your u or you can treat this as your v, whichever is more convenient to you. Okay, so you can solve these and you can comment down there on your answers. Okay? That's it. Okay, that's all for now. Thank you so much for watching. So we're done with the special products. So next time we'll be taking much advanced. Let's take further steps in order for us to discover a lot of topics regarding mathematical expressions, and in that way we will be able to use the mathematical expressions in solving word problems. So thank you so much guys for watching, and for those who are new to my channel, please subscribe now so that you will be updated on a lot of topics regarding math. I'm not just talking about mathematical expressions, basic algebra, but I'm talking math in general. So I will be able to upload a lot more about fields in mathematics like linear algebra, abstract algebra, calculus, and so on, as long as I will be able to explain it to you thoroughly. Thank you and have a good day.